Identifying a right-angled triangle. Trigonometry only applies on right-angled triangles. Is this a right-angled triangle?
I don't know. I'm not sure.
Why not? It looks like a right-angled triangle.
I'm not sure because it does not have the right-angled symbol.
Is this a right-angled triangle?
Yes, because it has the right-angle symbol.
Identifying the hypotenuse. How many hypotenuse in a right-angled triangle?
There is only one hypotenuse in a right-angled triangle.
There are two ways to find the hypotenuse of a right-angled triangle. Firstly, it is the longest side of the triangle, and secondly, it is opposite to the right-angle symbol. So which side is the hypotenuse in this triangle?
AC, because this side is the longest side and it is opposite the right-angle symbol.
Naming unknown sides.
Today we shall firstly learn the alphabet.
Skip that, I'm too smart for letters.
Now label this triangle with ABC. We are going to label the sides today. What do I name this side?
It's AB,
Why?
because points A and B are connected by this line.
Yes.
But can it be BA?
Yes, but it would be better if it was in alphabetical order.
Oh, I see.
Now name this side.
Easy peasy, CA, because the line joins points A and C.
No, it's AC. Remember, alphabetical order, although you are still correct.
Okay, I get it now.
Now name that.
BC?
Excellent.
Yeah, I know.
Why?
Because the line joins the points B and C.
Very good.
Opposite sides in a right-angled triangle. In triangle ABC, the Greek letter alpha represents an angle in a triangle.
What is the adjacent side of alpha?
The adjacent side of alpha is AB because it is right next to it.
Can the adjacent side of alpha be AC too? Because AC is also next to it.
No, it can't be AC because AC is already defined as the hypotenuse, the longest side in a right-angled triangle.
Okay, since we found the adjacent side, what is the opposite side then?
The opposite side is directly opposite to the angle alpha, so in this case, it is BC. The adjacent and opposite sides are named according to where the angle is in the triangle. In the same triangle, theta represents a different angle in the triangle ABC. What do you think is the adjacent side of theta? Remember, this is a hypotenuse.
If AC is the hypotenuse, then BC is the adjacent side.
Correct. Then what is the opposite side of theta?
I know, it's AB.
Correct.
Naming the unknown angle. Miss, I need help.
What is the problem?
How do I represent an unknown angle in a right-angled triangle?
Well, Linda, we use the Greek alphabet. The two common letters used are theta and alpha.
Are there any other ways to represent angles?
Yes, there is. As you can see, I have labeled each point A, B, and C.
So how do you find an angle then?
This angle is called ABC. It can also be called CBA.
How's that possible?
This angle is at point B, so therefore B has to be in the middle. Then just add the other 2 points in any order. Just make sure the main point is in the middle.
Today we will learn the 3 trigonometric ratios. Regardless of the size of the sides, we can define the sine, cosine, and tangent ratios of an angle. The 3 trigonometric ratios are sine theta equals opposite over hypotenuse, cosine theta equals adjacent over hypotenuse, and tangent theta, which equals opposite over adjacent.
Today we'll be instructing you on how to set up your equations for trigonometry.
To start off, we are going to show you sine. Sine is opposite over hypotenuse. In this diagram, opposite would be 4 and hypotenuse would be 7. After identifying these sides, we can write out our equations. Sine theta equals 4 over 7. The equation will be written out as sine theta equals opposite over hypotenuse. Therefore, sine theta equals 4 over 7.
Ratio cosine.
This is a right angle triangle because it has a symbol which means it is 90 degrees.
This is the unknown angle theta.
The side BC is adjacent or next to theta.
Theta.
And AC is the hypotenuse.
The trigonometric ratio of cosine for theta is cosine theta equals to the adjacent side over the hypotenuse. We use this ratio if it is convenient. For example, if we wanted to find BC and we had a value for AC, we can substitute it into the cosine ratio.
In this triangle, we will be using cosine.
Why are we using cosine?
Because cosine is adjacent over hypotenuse, and in this diagram they have given us these sides. After identifying the sides, you put it in an equation which will look like this. Cosine theta equals 5 over 9. When will we be using tangent?
Tangent is only used in right angle triangles, which have given you the sides opposite and adjacent. Because tangent is opposite over adjacent, we write the equation like tan theta equals 10 over 12.